Okay, so today we're going to work on compound interest. Your homework / work for the class today is to fill in the notes and submit them. Okay, so that's what your homework is. So today we're going to look at compound interest. Now, population and money growth can be represented as exponential functions. There's nothing better than when your money makes money. So, there's two formulas we're going to look at: not continuous versus continuous. The formula for something that's continuous is the amount of money you have is the P, principal, which is the starting amount, times E. E is, again, that number. Remember, use that button on your calculator. It's that number we talked about a while ago. That represents about 2.714. Raised to the R times T. R is your rate, and T is your time. So notice R is your rate. Now, for example, if somebody says 5%, you have to put a 5 in that spot, because remember, if you have 5%, you have a dot there, decimal, right? 5.0. If you go from percent to decimal, you move 2 to the left. So the dot decimal will go there, and your R would be 0.05. So this is a common mistake when people plug in values in for the rate. And T, we said, is time. And when we look at time, we're talking about, so you need to pay attention to time, just like rate. These are the two things that are a little bit funky. So if somebody says time, if the word problem says time is in terms of years, and they say how much money do you have after 5 years, and time is in terms of years, you would plug in 5 for T. However, if the word problem says that time is in months, right, and they say how much money do you have after 1 year, you would not plug 1 in for T, because it says that T is in months, and 1 year is the same as 12 months. So just pay attention to that. And going back up here again, we said A is your final amount of money that you end up with after all of this happens, right? After all of this has happened. And then P stands for your principal, your starting amount. So notice that our P's are in the same spot. They're our first variable that we see. So continuous is A equals P e to the RT. That's continuous. The word problem will say your money's continuous, or it will say your money is compounded. I'm talking about compound. Your money is compounded every month, every week. That's when you would go with not continuous, when it says it's compounded every month, every week. Okay? And when it says it's compounded every month, every week, we know we're going with the non-continuous formula, which has that N in it, right? So N is the number of times it's compounded in a year. So if it says compounded daily, you say how many days are in a year. There's 365. You always say how many of that thing are in a year, if N is in terms of a year. If it says monthly, well, how many months are in a year? There's 12, right? So N would be 12. So quarterly, let's do another one. How many quarters are in anything? There's 4, right? 4 quarters in a dollar. You can split anything like a game into quarters, so that means there's 4 quarters in a game. So with all that being said, let's look at the first problem. Again, you guys are going to fill this out and then submit it as your work for the day, okay? So let's look at number 1. In number 1, it says, following the birth of a child, Juan deposits $10,000 in a college fund trust where the annual interest is 6.4%, compounded semi-annually. So the first part is you need to figure out, is it continuous or non-continuous? Now, when it says it's compounded semi-annually, quarterly, we know that it is the non-continuous formula. That's important that you figure that out first. So we know that it's A equals P times the quantity 1 plus R over N raised to the NT. So let's start to fill stuff in. We know that the starting amount that Juan deposits is 10,000. So that's our P, our principal, right? We know that the rate, we don't plug 6.4 into the R spot. We don't plug 6.4 in because we need to go from percent to decimal, so we move this dot 2 to the left. So it becomes 0.064. Now, we know that R goes right here, that's a 0.064. It says, write a function for the amount and account after t years. They don't give us a specific t, and they want a general formula. When you have a general formula, right, y equals, let's say 3x plus 2. We need a variable on the left and the right for input and output. So for this problem, we're going to have the a on one side, and we'll have the t on the other side for input and output. Input would be time, output would be amount that you've earned. Now, what else do they give us? They say semi-annually. So n is the number of times compounded, right, in a year. So semi means 2. So that's why I plug a 2 into the end slot. Notice that the 2 goes here and in front of the t. So your general formula is a equals 10,000 times quantity 1 plus 0.064 over 2, close parentheses, raised to the 2t. Okay, now it says find the amount of money after 0 years. Well, 0 just means initial, okay? So if you put a 0, you use that formula we just came up with, and you put a 0 into the t spot, right? 2 times 0 is 0. Any quantity in parentheses raised to the 0 power is 1, and 1 times 10,000 is 10,000. And that makes sense, right? At 0, at initial time, you have what you started with, $10,000. Then if you plug in 4 into the t slot, 2 times 4 is 8. If you do this value in parentheses first, raised to the 8, enter, times 10, enter, you get 12,865.82. Notice your money is growing rapidly, right? That's why you don't just want to put it in a savings account. You want to put it somewhere where it's going to grow rapidly, exponentially, right? A variable is an exponent. Then after 10 years, 2 times 10 is 20, quantity raised to the 20, enter, times 10,000 is 18,775. Wow. So your money is growing quickly. So for this next problem, we're still using that same formula, right? The amount equals the 10,000 times the 1 plus 0.064 over 2 raised to the 2 times t, right, semi-annually. So now we're going to work backwards. How long will it take so we're trying to find this value, the time, right? How long is it going to take for his fund to double? Now, if we know he started with 10,000, that's the principal. The final amount would be 20,000. So we know when we're trying to solve for a variable that's in exponents, we're going to have to use logs. Now, the parentheses is a set, right? So we can first divide by 10,000, which you see up here. Divide both sides by 10,000, and we end up with 2 equals, and we simplified inside the parentheses. So 1 plus 0.064 over 2 becomes quantity 1.032. So it was 1.032 raised to the 2t. Now, you look at the side that the variable is on. It's on the right. When your variable is an exponent, we need to use logs. So we do log base 1.032 on both sides. On the right, it cancels. So on the left, we have log base 1.032 of 2 is equal to 2t. Remember, when your base and number, the base and of are both a number, this is a value, right? You put in your calculator. Log base 1.032 of 2 becomes 22.01. So we have 22.01 is equal to 2t. Then we divide both sides by 2, right, which is what we show you here. And when you do that, you get t equals 11. So this is our answer. After 11 years, our money will double.